Hi children, welcome to today's online class. First we are going to see properties of electric field lines. Properties of electric field lines. Yes, at the previous class we have seen what are electric field lines, and we have drawn the electric field lines due to different configuration, the isolated charge and combination of charges, etc. etc. Now we are going to see properties. Okay, the first property actually it is the definition itself. What is that? What is the definition? It is an imaginary line or a path drawn in an electric field such that the tangent drawn to it at any point gives the direction of the electric field at that point. I'm not going to write everything, but just you take a note of it, okay? So what is that? It is an imaginary. First one is the definition itself. First property, very important property. The definition itself is a property, right? Therefore, it is an imaginary line drawn in a electric field such that the tangent drawn to it at any point gives the direction of the electric field at that point. Okay. Now what is the first one is definition. Okay. Then what is the second one? Second one is, say, the electric field lines, they start from a positively, first one is definition. Okay. Then second is they start from, the electric field lines start from, okay, they start from positively charged body and end at a negatively charged body. Okay, charged body. But you can say no field lines exist inside the charged body. Inside the charged body. You cannot see any, there is no field lines exist inside the charged body. Therefore, you can say, how to summarize, therefore, electric field lines are continuous, they are continuous lines, okay, but do not form closed loops. I think you would have studied your magnetic field lines in 10th standard, right? Therefore, inside a magnetic field lines, they go from north to south. But inside the magnet also there will be magnetic field lines. Okay, recall your 10th standard. If there is a magnet, see, anyhow, because we have studied, that's why I just want to recall. For example, if it is north and if it is south, okay, therefore the field lines, they go from north to south. Here, electric field lines, they start from positively charged body and end at negatively charged body. But here, in the case of north and south, in the case of magnetic field lines, they go from, they start from north and they go to south. It goes from, and but it won't stop here. Actually, it forms a closed loop. After that, it forms a closed loop like this. So inside the body, it goes from south to north. Outside, it is going from north to south. Are you following? Therefore, if it is like this, it goes, and inside it will be like this. Okay. Therefore, outside the magnet only, the field lines are from north to south. But they form a closed loop, no, north to south, and inside it is going from south to north. So they form a closed loop. Like this is magnetic field lines. This, why I am actually here I'm telling this one, why? Because you have already studied in your 10th standard about magnetic field lines, right? Okay, but here in the case of what is that electric field lines, for example, if it is a positive charge, already we have seen negative charge means, okay, it goes from positive to negative charge, but that's all. After it won't go inside and it comes like this. No chance. It is not at all possible. I think you are following me. Okay, so it won't go like that. So there won't be any magnetic field lines, electric field lines inside a charged body. So it starts from a positive charge and ends at a negative charge. This I think field lines you have already drawn up. So this is here. Okay, right. Then this is the second what is that property. And third property. Third property means so it forms what is that? No two electric field lines can intersect with each other. So it is going like this, means somewhere here is your positive and here is negative. Why? Because the field lines go from positive to negative. So like that, I have to, for example, actually no two electric field lines can intersect with each other. Okay, so how, for example, I am taking, if it intersects, AB is one line and XY is another line. Here is somewhere positive and here it is X side positive and Y side is negative. So the line, it goes from positive to negative, right? But they actually, here it is intersecting. This is the point of intersection O. If they intersect, what will happen? See, you know very well magnetic field line, it is electric field lines or imaginary line drawn in an electric field such that the tangent drawn to it gives the direction of the electric field. Therefore, at O, if you draw a tangent to AB, the field line AB, then this will be the electric field, correct? This will be the electric field, direction of the electric field. But at the same time, okay, O lies on XY also, because it's the point of intersection. According to XY, if I draw a tangent from O, then it will be in this direction. Are you following? Therefore, at O, this is electric field is in this direction. Okay, therefore, at O, okay, there are two directions for electric field, correct? There are two directions for electric field, which is not possible. At one point, the direction of electric field will be only in one direction. But if the two electric field lines, they intersect with each other, at the point of intersection, you can have two directions for the electric field, which is not possible. Which is not possible. Is it clear? Right. Then next one, we'll see. Third one. And next one is, okay. See, the electric field lines, okay, are always normal to the surface of the conductor. Charged body. Conductor is charged. Therefore, if you are drawing the field lines, it always emerge normal to the surface of a conductor. What are whether both while starting, where it will start positive charge body, okay, or if it is positive charge, or ending where it ends at the negative charge, okay. Therefore, ending on the conductor. Okay, therefore this is very important. So always it is normal only. If it is normal, if it is a positive charge body, okay, here it is positive. Okay, So as I told, according to this, what is that? The electric field lines will always start normal. Normal positive charge will be going like that. Already we have drawn now. Right. So which means that you cannot, what is it, if it, since it is normal, it cannot have any component, tangential component here, in this case here. There is no component of electric field which is parallel or tangential to the surface of the conductor. Okay, that is very important. If it is, for example, why? If it is traveling like this, for example, if the electric field lines are, if it is like this, then it will have two components, one in this direction and one in this direction. Hope you are following me. Okay, so if it emerges like this, then it has two components, one normal and the other one is, what is that? The other one is tangential, that is parallel. But in actual practice, you cannot have, okay, always electric field lines are normal to the surface of the conductor. There is no tangential component. Okay, that is very important. Right. Next one is electric field lines are all, actually lines contract longitudinally. Electric field lines contract longitudinally, okay, on account of, actually on account of attraction between two unlike charges. Unlike charges can attract, na? So because of the attraction, electric field lines contract longitudinally. I think it is correct only. Positive, negative. Okay. So how is it? See, it will be like this, like this, like this. So both the side contract, it is longitudinally. Okay, I think this is correct only, na? They contract longitudinally. As you come like this, it is contracting longitudinally. So this is very on account of attraction between two unlike charges. Then sixth one is electric field lines. Okay, we'll go to the next page. See, next one is electric field lines exert a lateral pressure, on account of what? Repulsion between two like charges. What is that? Two like charges here, positive. Okay, therefore now you know how the lines will be. It goes, you know, what is it? You have to keep a unit positive charge. Therefore, what is the path of the path traced by the unit positive charge gives you the what is the direction, right? Direction of the electric field. Therefore, if you keep a unit positive charge, it goes, but because here also positive charge here, therefore it will be repelled. I think the previous class we have seen, no, like that. And here also like this, right? Therefore, what is that? That is the lines actually show that as if there is, what is there, some lateral pressure. That is why what they are diverging here. These lines are here, you see the lines here, see here, they are actually, okay, they are diverging. No, they are diverging, which means that, okay, they are repelled, you can say they are repelled. So, and it seems as if they are experiencing some lateral pressure. Okay, so the electric field lines exert a lateral pressure on account of repulsion between two light charges. Right. Then next one. What is next? See, next one is C. Closer the lines, denser. Okay, closer or denser. Denser the electric field lines in a region. Okay, means in a region means the electric field is okay. Even I can closer the electric field lines in a region, stronger is the electric field. Okay, or okay, what is that? If denser the lines. Okay, but here when the field lines are far apart, okay, far apart, then electric field in that region is weak. Okay, so the field lines give you, if the density, okay, density of lines is more, means in that region electric field is strong. Therefore, for example, see, for example, like that, very, very close. Here it is stronger. The field is stronger here. Stronger. The field is, okay, stronger. Strong electric field. Okay. But if the field lines, for example, see, if the field lines are like that one, like that, okay, then it says that after that here, okay, so they are far apart, which means that it is a weak electric field in this region, here in this region, okay, here in this region, okay, field is weak field in comparison. I'm telling, here it is strong and here it is weak. Okay, weak, which field? Electric field. After that, don't say, okay, so weak electric field. I'm happy that you are following the lessons very nicely, and many are asking doubts also. That's good. Okay, so therefore this is the next what is that, a very important property. So from this I think you can even find out electric field intensity. From what is electric field intensity? See, electric field intensity is nothing but already you have force per, what is force experienced by unit positive charge when it is kept at that point. Okay, electric field intensity at a point. But with respect to, you can give one more definition with respect to electric field intensity. With respect to electric field lines also. I am going to define electric field intensity in terms of, what is that? Electric field lines. How? Electric field intensity at a point, okay, is equal to number of electric field lines crossing normally per unit area around that point. Per unit area around that point. Are you following? Therefore, if you want the field at this point, electric field intensity at this point, okay, so per unit area, take one unit area around that point, how many field lines are crossing normally? crossing normally. Okay, so it is what is it? You cannot even say it here normal. It is crossing normal. It is a surface now. So I'll give you the definition here. What is that? Here is a point and take a unit. What is the area around that point? How many field lines are crossing? Okay, normally per unit area which is taken around that point. That gives you the electric field intensity at this point. Are you following? So you can define electric field intensity in terms of what is that? Electric field lines also. Got it? Therefore, that's it. I think even if you want, this also can be written as one of the okay, let me write y NSSC. I'll write 8 point. This one as a 8th point. What is 8th point here? 8 point is electric field intensity, okay, at a point is, okay, equal to the number of, okay, electric field lines crossing normally, very important, normally per unit area around, taken around that point. Whichever point you want, around that you take unit area, how many lines are crossing, that gives you electric field intensity. Are you following? Right, this is about properties of electric field lines, right? Now, next one is, what is electric dipole? What is electric dipole? That we will see in the next slide.